5.3, Day 2, Real-World Applications, Systems of Linear Equations. Yes, that goes along in your textbook around page 213 or so in the book if you need to follow along. Again, feel free to highlight anything, circle anything, stop, pause the video, highlight anything that you're not understanding, and make sure you ask me in class tomorrow. So here's question 1. Sasha has a riddle. There are two numbers. The sum of the first number and twice the second number is 14. When the second number is subtracted from the first number, the result is 2. What are the two numbers? So I have two unknowns. What are the two numbers? So I'm going to write two let statements. Let x equal the first number, and let y equal the second number. So two unknowns. Sasha has a riddle. There are two numbers. The sum of the first number, and twice the second number, summing them, is 14. So x and 2y is 14. Sum of the first and twice the second is 14. When the second number is subtracted from, so minus y, the second number, it's going to be minus y, subtracted from the first number, so x minus y, the result is 2. So I'm going to either use substitution or elimination to get rid of the variables. I think I'll do substitution this time because I can solve this equation for x equals y plus 2 and put this expression in for that x. I think I'm going to substitute that in. So y plus 2, my x, plus my 2 y's has to equal 14. So subtracting 2 from both sides and combining my y's at once, I get 3y's is 12. Dividing by 3, I get y is 4. So if y is 4, x minus 4, the y has to equal 2 from the original equation. So adding 4 to both sides, I get x equals 6. So y equals 4 and x equals 6. I'm going to mental math check this. So 6 plus 2 times 4, that's 8. 6 plus 8 is 14. So it checks in that equation. 6 take away 4 is 2. So it checks in this equation. I did a mental check. It works in both equations. Now I'm going to sable. What are the two numbers? The two numbers are 4 and 6. So I checked, answered in a full sentence. On to question number 2. Christopher is thinking of two positive integers. So I know they can't be like 3 5/10. Positive integers, whole positive sign numbers. The sum of the integers is 27. Well, that's one of my equations. When twice the first integer is added to half of the second integer, the sum is 24. That's my second equation. Find the integers. So there are two positive integers. So I'm going to say let x equal the first positive integer. And let y equal the second. Got to find two things. The second positive integer. The sum of the integers is 27. So x plus y is 27. When twice the first, so that's 2x, is added to half of the second half of y, the sum is 24. When twice the first is added to half of the second, and I could do y over 2, or 1/2 of y, half of y, the second, the sum is 24. There's my two equations. Now I could either substitute or eliminate. I think I'm going to substitute again. I rarely do that, but a little practice would be good. So this equation would be, I'm going to solve it for x this time. Negative y plus 27. And I'm going to substitute that in for this x. A little bit harder. It probably would have been easier to eliminate. Negative y plus 27 plus half of y is 24. That might have been easier to eliminate, but that's okay. We can do it a couple ways. You could try it another way and see if you get the same answer as me. That would be great. That would be good practice. Negative 2y plus 54 plus a half of that y has to equal 24. Subtracting 54 and combining my like terms, I'm going to get negative 3/2. Negative 2 plus a half is negative 3/2 y has to equal negative 30. Well, multiplying by the multiplicative inverse on both sides, multiplying by negative 2/3, yes, my nice rational coefficients are going to go away. And y equals 3 goes into 30, 10 times negative 10 times negative 2 would give me positive 20. Y is 20. So what plus 20 equals 27? Well, x has to equal 27. So 20 plus, I'm sorry, not 27, 7, silly me, not 27, 7, x equals 7. So that makes sense. 7 plus 20, checking into this equation, is 27. 2 times 7 is 14, and half of 20 is 10. 14 plus 10 does equal 24. I mentally checked to make sure that y equaling 20 and x equaling 7 simultaneously works and checks in both equations. So I did a mental check again. I didn't do a full written out check, but I did check to make sure my answer is correct. The integers are, and yes, they are integers, whole positive sign numbers. So the integers are 20 and 7 is the SABLE, or sentence answer box label as I call it. The integers are 20 and 7. Full sentence answer. Third example and the last example. A restaurant sells 4 combo meals. Jolly meal, which costs $12.60, consists of 2 yogurts and 1 sandwich. The special meal, which is made up of 2 sandwiches and 1 yogurt, costs $13.50. Calculate the cost of the following combo meals if the charge for sandwiches and yogurt cups are the same for all of the combo meals. Okay, so there are 4 of them all together. They're giving me 2 of them. That's my 2 equations. And then I have to do something with the answers that I get for a yogurt cup and a sandwich to figure out the children's meal combo and the family meal combo. Ooh, an extra step in this one. Okay. So for the Jolly meal, which consists of 2 yogurt cups and 1 sandwich. So y is the yogurt cups, that's what I'm going to say. I have a lot of space here. And x, I'm going to call the sandwich. Or maybe I'll say S for sandwich. Yeah, I'll use S. Let S equal the sandwich price. So, Jolly. This is Jolly. The Jolly meal, which consists of 2 yogurts, so 2 yogurts plus 1 sandwich, is $12.60. And the special is 2 sandwiches and 1 yogurt, which costs $13.50. So, I think I'm going to eliminate. I'm going to multiply this by -2 and get my y's to cancel. So -2 y's and -4 sandwiches equals -27. So combining those, I get -3 sandwiches equals -3 sandwiches equals -1440, maybe. So a sandwich, when I divide both sides by 3, a sandwich, dividing both sides by -3, I get a sandwich equals 480. So if a sandwich equals 380, a yogurt plus 2 of those sandwiches has to equal, using my second equation, the special combo meal, $13.50. So that's $9.60. And when I subtract $9.60 from both sides, I get that a yogurt costs $3.90. Must be one of those fancy yogurt parfaits or something. So a yogurt costs $3.90. 3 sandwiches, so a sandwich is $4.80 and a yogurt is $3.90. So that would be, calculate the cost of the following combo meals. Oh, that I don't have to sable that, but that is the sandwich. So 1 sandwich in the children's meal would be $4.80, and 1 yogurt, which is $3.90. What's the cost of the children's meal? Well, that's $8.70. And then 2 sandwiches in the family meal, well, 2 times 480 would be $9.60. And 3 yogurts, 3 times $3.90, that's $11.70. So that comes out to be $21.30. Calculate the cost of the following combo meals if the charge for the sandwiches and the yogurt cups is the same for all. So the children's meal is $8.70 and the family meal would be $21.30. And that's it for today. We'll practice some more of these in class, the next class.